Hi everyone, hope you are doing great. Now, in this particular video that we have come up with, we will talk about the normal distribution and try to give a more intuitive explanation, skipping the hard technical terms, the mathematics behind these distributions, and all of those. Now, why the normal distribution is really important is because in the study of data science or data distribution specifically, the normal distribution, or also popularly known as the Gaussian distribution, holds a really important place. It is one of those many statistical distributions that is extensively used in various fields in the spectrum of data science applications. Now, often in most machine learning models, a crucial assumption is that the data that you are looking at needs to follow a normal distribution, and the entire set of tools or technologies, algorithms, whichever you are applying for these models are mostly based on this underlying assumption. Now, as you can then understand that it makes this particular topic really important for you to understand, at least in some depth. Now, while there is a lot of mathematics and technicalities also involved in this particular topic of distribution, which we would, at least touch upon in some more depth in some of our other sessions, specifically on sampling and probability and sampling probability distributions. The intent in this particular video is to keep it short and to the point. Here we would try to talk about a more casual interpretation of this normal distribution. Often people in business, they are not too statistically in depth, to know all the terms or the technicalities behind these terms in this particular field. In order to explain them this concept, you would need to avoid certain technical terms and jargons and maybe explain them in a more basic way, which we call as explaining something in layman's terms. Often in data science interviews, an interviewer might ask you this particular question that, what do you understand by a normal distribution in layman's terms? Now, if you go to him or her and answer this question in a technical way, the person might not really be impressed because you are just, it might seem that you are mugging up a definition from the book and just trying to explain that to somebody. So a non-technical person, a person who is not from the statistics background, might not be able to infer what you were talking about. So let's look at how we can understand the normal distribution in a more intuitive way and somehow try to avoid the mathematics as much as possible. Now, before even diving into the concept of distribution and normal distribution, let's take a step back and maybe talk a bit about what statistical inference is all about. So, the analysis that we generally do, any kind of model building exercise or data analytics projects that you guys will be working on, heavily relies on this one particular topic of statistical inference. Now, what is really meant by this topic of inference, and we'll again cover these in more depth in the relevant sections when we cover them on inference, on estimation, hypothesis testing. But for now, in simple terms, what statistical inference talks about is that you have a piece of data that you can observe, right? And this is part of a bigger universe of data, a bigger data space, which you can think of as what is also commonly known as the population. So what you can observe and what you can measure is just a sample out of this particular population. Right? Now, in order to, so whenever you are doing an analysis, what you are trying to do essentially is that you are trying to model on this particular observed data. You are trying to mine and mine some knowledge out of this data, discover patterns from this data, and trying to generalize or say something about the broader data space or about the population. Right? So this entire concept is that of statistical inference, where you are reading and studying a fraction of the data and trying to say something about the entire population. So just as a basic example, if you were trying to draw a conclusion that most people who are smokers have lung cancer. Now, if you would have tried to say this based on scientific methods, all you would be doing is you would have some data that you read, you study, and then you come up with this conclusion that it's not really possible to study the data of all human beings on earth. You cannot study, maybe have the history of smoking for all the individuals. So what you generally tend to do is you study a small sample, and based on statistical measurements, on different analysis and insights, after you attach a certain amount of confidence to your results, you can then confidently say that, based on the data that we have studied, we think that there's a high degree of correlation or association between smoking cigarettes and lung cancer. And this is exactly where the concept of distribution plays a really important role. Now, how it does is basically, in order to generate certain conclusions from a sample, you need to basically have certain desirable properties in the distribution of the overall data or in the population, right? which were ideally not being able to observe. And a very good property of a distribution is if that particular distribution is symmetric about some central value. This offers a lot of mathematical flexibility, and it's also somewhat fine-tuned with reality, although not always the case, but that's how the natural processes are, that it should follow a normal distribution. So normal distribution is more like a distribution of probabilities. Why probabilities? Because when you are talking about concepts surrounding population, you are not able to observe the data points, and that is why we attach the concept of probabilities with unobservables. So this is normal distribution is more like a probability distribution which is symmetric about the mean or any uh, measure of the average. Let's take in this case the simple mean. What this tells us is that the data following such a distribution has more data that is clustered around the mean, or in other words, more frequent data. So more data is clustered around this mean as compared to the data that are farther away from it. So if you imagine this visually, this would look like a bell-shaped curve. So this has to be symmetric. Let me draw this out here. So imagine this is your axis. So this has to be symmetric, right? So this point is mu, or what is known as the mean. So this is the mean of the distribution, and there's equal areas on the two sides of the mean, 50% and 50%, assuming that the entire area under the curve is 100%. Right. So this is a bell-shaped curve. Now, a caveat to note here is that it's not always necessary to believe that your data in the population should necessarily follow a normal distribution. Although it's assumed that a population generally should follow or would follow a normal distribution, there are various business processes that could generate distributions which are not at all normal. Because often business processes, what they tend to do is they try to control for certain factors in order to improve the performance or maybe productivity, which results in data which are a little skewed. And these are artificially distorted in this kind of controlled environments, right? So take the example when you are looking at maybe the count or the number of phone calls that is received by a particular telephone operator, maybe throughout the different hours on a particular day. This, if you imagine, would not follow a normal distribution, right? Or maybe even if you're looking at the product life cycle of a product, maybe you can take the example of a battery over time. it might be having an exponential distribution for that matter. Right? Now, imagine that you are studying maybe a manufacturing process or a workflow which has several components in it. At each stage, you are trying to read or record how many defects are coming out of a particular machine. Now, let's say you are measuring the average, quality standard of these outputs, and you are measuring the quality at a standard which is mu, let's say, or this is often referred to as x bar when you are looking at the sample. So mu is generally represented when we are talking about population, and x bar denotes the sample mean. We will talk about these things when we talk about the difference between a sample statistic and a parameter, and these concepts will be dealt with when we talk about sampling and population in more depth. Now, for the matter here, what we are trying to say is that if this is your standard that you are measuring a quality, the manufacturing quality at, now any deviation from the mean is measured by what we are calling as standard deviation. So it's a deviation from a central value. Now, given this process, it is often rational to expect that there would be lesser number of defects that are far away from the central value. Right? So here, if you imagine, the cases are much lesser than the cases which is closer to the mean. So if you, this looks like a probability distribution, but if you were to think of this as a simple frequency distribution where you are observing the data, so this is your x variable and these are the corresponding frequencies, and now if you're trying to plot this particular distribution in some way, so generally what happens is that just to digress a bit over here, although you might not need all those technicalities, just for the sake of understanding, if you look at the mathematical form of this particular distribution function, so it ranges from minus infinity to plus infinity, right? And that is where this concept of asymptotic comes into the picture, where it doesn't really touch the horizontal axis, right? And this is a topic that is conceptualized under a famous theorem, which is known as the central limit theorem, or in short, CLT. What this states is that as we increase the number of samples, or in other words, the sample size, the means or the averages of our samples would tend to approximately follow a normal distribution. Now, as you can see from the particular figure out here, that the normal distribution 1 is definitely a symmetric distribution, where by symmetric we mean the area on the left hand side of the mean is exactly equal to the area on the right hand side of the mean. It's an inverted U shape. One other important property of the normal distribution, apart from being symmetric, is that the mean is equal to the median, which is also equal to the mode of the distribution. One other important property of the normal distribution is it should be unimodal, which means that the distribution should have just one mode, which is one point which it can one point with the highest frequency. So imagine if you're looking at a curve like this maybe, right? So in this case you have three peaks with the same frequency. So this is no more a unimodal distribution, this is a multimodal distribution, and this is not considered to be a normal distribution. A normal distribution should always have one particular point with the highest frequency. One other important, this is not exactly a property but this is a feature of the normal distribution, is that around 68% of the data lies between plus minus one standard deviation from the mean. Similarly, around 95% of the data falls in between plus minus two standard deviations from the mean, and almost 99.7% of the data falls in between plus minus three standard deviations from the mean. Right. Now one other important thing that we need to talk about here is that how does somebody exactly know that the distribution that we are looking at, is it normal or is it not? So there are many ways to understand if the distribution is normal or not, and one of the particular popular visual techniques is that of histograms. So histograms is basically where you are looking at the different fields or groups of the data or the variable that you are looking at. For example, there is a variable x, and there are different groups of this particular variable. So if you have looked at class intervals, maybe this will make sense. And similarly, you have different other groups. And what you do is on the y-axis, on the vertical axis, you have their frequencies, and you plot those frequencies against these class intervals, right? And then you plot all of these. Now, if it assumes a symmetrical shape, then you are quite sure that the data that you are looking at tends to follow a normal distribution. You could also look at other graphs like box plots. This is also known as the box whisker diagram. You could also look at that, or this is also called the 5 summary plot, things like that. So there are multiple terms. So here basically you can try to figure out where exactly the mean is, where the median is, and all of those things. You could also simply look at the three numbers, which is the mean, the median, and the mode. And if these three numbers are equal, then you know that you are looking at data which is normally distributed. So that's all that we had to discuss today, and I hope that you have learned something new. If you're looking for any private mentorship or career counseling, private mock interviews for being well prepared to ace your data science interviews, or even if you're looking for any kind of guidance and training on data science, specifically if you're just a beginner, then what you can do is you may fill up the form that's provided in the description section below in this particular video, and one of our support team members would get in touch with you. Now, most importantly, don't forget to click on the bell icon and press the subscribe button to stay updated about our any such new interesting and informational videos that you definitely do not want to miss out. Stay tuned and wait for our next video, and we would catch up soon. Thank you for watching.